Welcome back to Behind the Print podcast, where we feature industry leaders and uncover the creative minds and their businesses within the world of professional printing. Our mission is to provide you with inspiring, actionable resources that elevate your business projects and accelerate your journey to excellence in profit and print. Today's episode is Studying the Universe with Radio Astronomy, and we have a special one lined up for you guys today because I'm here today with the National Radio Astronomy Observatory Director of Science Communications, Brian R. Kent.
Hi there, everybody. Hi, Zoe.
Hey, so how's your day today, Brian?
Oh, we're doing just fine here in Virginia.
Amazing. Can you start by telling us what the National Radio Astronomy Observatory does and what your role as the Director of Science Communications looks like?
Sure, absolutely. So my name is Brian Kent. I'm a scientist and Director of Science Communications here at the National Radio Astronomy Observatory, NRAO. So the NRAO is a facility of the United States National Science Foundation, operated by Associated Universities Incorporated. So at the observatory, I lead our science community presence at conferences around the world. I'm also interested in studying nearby galaxies in the universe, data visualization, and 3D graphics.
That is so interesting and inspiring. Wow. So who are you trying to reach through your work in science communication, and why is it important to bring astronomy to broader audiences?
So I focus on the scientific users of our telescopes and astronomers around the world. Our scientific facilities are used by astronomers and students to study a large range of astronomical phenomena in the universe. So it's important that astronomers and the public understand the importance of our research, what we learn from it, what we gain in terms of scientific knowledge, and how technology that we develop here furthers development in human society.
That's amazing. A huge step in advancement into the future of technology, too.
Absolutely it is. Absolutely it is. There's a lot of really interesting pieces of technology that have applications outside of our field that are developed for the radio telescopes, including the ones that you see behind me here in the background. Those are telescopes in New Mexico. That's called the Carl Jansky Very Large Array, and that's one of the facilities that we operate.
Wow, that's amazing. So what are some of the most exciting or challenging problems you help solve through your visualizations and research?
So astronomical data can tell us a lot about the inner workings of galaxies, planetary disks, and events that, create things like gravitational waves. So when we collect large amounts of data in our survey projects, and when I say a large amount of data, your Android or iPhone might have something like 128 gigabytes of storage space, and that's a lot. Although we always need more storage space on our mobile devices. But the data that we take, we're talking about terabytes of data in a single data set. So it's a lot. But when we do these large surveys, astronomy is a little bit of it's a science of a time machine. And so we can actually look back in time at the evolution of galaxies and star formation and the formation of solar systems very much like our own. So we take enormous amounts of data with these incredible telescope facilities, and it tells us something about how we got to where we are today, which is really, really an interesting part of astrophysics.
And how do you take such complex data like that and turn it into something that people can actually see and understand?
Right. So we operate telescopes in North America and South America with our international collaborators. These telescopes include the Robert C. Byrd Green Bank Telescope in the eastern United States in the state of West Virginia. This is a 100-meter telescope doing fantastic science with objects called pulsars. These are rapidly rotating neutron stars, time domain astronomy, radar, astrochemistry, studies of neutral hydrogen, which is the first element on the periodic table. But we can't build a telescope many kilometers in size. So we have to get creative, and scientists and engineers are creative people. So what we do is we use a technique called aperture synthesis. So we use many smaller radio telescopes to synthesize an aperture that would be tens of kilometers in size, and we can get incredible resolution at radio frequencies. So think more pixels on your cell phone kind of thing. We're always excited when the camera on our mobile phone improves because then we get higher resolution pictures. And in the print business, the name of the game is resolution. So we like to have a high resolution in our radio telescopes. So again, the telescope behind me, the Carl Jansky Very Large Array in the state of New Mexico, is one of those aperture synthesis, what we call an interferometer. So one of the most scientifically productive ground-based facilities ever built. It's currently engaged in a large project called the Very Large Array Sky Survey, or VLAS, which is cataloging the radio sky in high resolution. It's a project whose data are available to the entire astronomical community. So roughly a couple weeks after the data are taken off the telescope, you can start getting those data for your scientific studies. So it's a real nice project in that everyone has access to those data. So you can study active galaxies, time domain science, the magnetic universe, imaging galaxies through space and time, and galactic science, studying our own Milky Way galaxy that we are in. And we also have another telescope that actually goes all the way across North America called the Very Long Baseline Array, the VLBA. And that's composed of telescopes from the Virgin Islands to the island of Hawaii. And what you end up doing is creating a radio telescope the size of planet Earth. So one of the highest resolution instruments ever created. That's also operated, its headquarters are in New Mexico. And then finally, we have ALMA, which is the Atacama Large Millimeter Array in Chile in South America at 5,000 meters, highest, driest place on Earth. You can put a high-frequency radio telescope. It operates in the millimeter and submillimeter, so you're looking at the higher end of radio astronomy. It's making groundbreaking discoveries with protoplanetary disks where we're seeing solar systems in the beginning of their formation, astrochemistry, and mapping the molecular gas content of galaxies. So these telescope facilities are used by astronomers in many different ways to study all different kinds of phenomena.
That is just amazing. I love how everybody can use the data. That's really cool.
Absolutely.
Everybody can work on their own projects and use that same data. Really, really interesting.
That's right.
So how do you approach, I've seen your books, how do you approach storytelling when communicating these complex topics?
So as I mentioned, we do a lot of conferences, both in the United States and around the world, and we talk to our international colleagues, and we have exhibitions where we are telling people all about the potential of our facilities, what you can do with them now as a scientific user, and what we want to do in the future. And that requires, as a community feedback so that we understand what people want to study scientifically in the future, and having products there, both print and digital, provides astronomers with the materials that they need to make informed decisions about how to best use our telescopes, because we want to maximize the potential of our astronomical facilities and to maximize scientific productivity. So this is really important with new users and students who may be new to radio astronomy. So you might have people who are using space-based optical or infrared or X-ray telescopes, and they make interesting astronomical discoveries, and they say, well, okay, we want to study those in the radio. That composes what we call the electromagnetic spectrum. X-rays, ultraviolet, optical, infrared, millimeter, radio. It's the entire gamut of the electromagnetic spectrum that we study in astronomy, and radio makes up a very, very important part of that. So it's important that we have materials that are concise and easy to use so that people in the astronomical and scientific communities can understand what the possibilities are with our telescopes. And so that's one of the important things that we have to do.
For sure. It gives them a leg up on learning the technology so that they could spend more time in their own research.
That's right.
So what sets your work apart from other science communication efforts in the astronomy world?
So we are unique. We operate world-class facilities in the radio part of the spectrum, both in the northern and southern hemispheres. So we are excited at NRAO to expand the observational capabilities of our telescope facilities in Chile. This is the ALMA telescope, the Atacama Large Millimeter Submillimeter Array. And so that's something that astronomers and engineers are actively working on right now. The other great project that NRAO is really interested in is embarking on a new telescope project in the American Southwest called the Next Generation Very Large Array. So this prototype telescope is being assembled right now, and you can actually watch it live on the NRAO webcam. We have the first telescope that is being assembled, and this telescope will, in the future, consist of 244 radio telescopes in the American Southwest that astronomers will use to continue studying the universe in high resolution.
Wow, that is extremely impressive, and I cannot wait for it to get up off the ground. That's going to be a huge milestone for you guys.
It'll be a lot of fun, absolutely.
Are there any specific visual projects or moments in your career that really stand out to you as something that you're especially proud of?
Well, I think astronomy is a very collaborative science. So it's not just one single person figuring out the answers to our scientific problems. So I think that collaborating worldwide with many different groups of people and talking to them and figuring out, well, okay, where do we want the field to steer towards next? Whenever we, for lack of a better term, gaze out into the universe and see new, interesting objects and astronomical phenomena, what it typically does is raise more questions. And so that's the scientific process. We iterate, we figure out how to improve our telescope facilities and how to maximize their potential. And that's one of the advantages of having our telescopes here on the ground is that we can continuously upgrade them. And so when we figure out new technology advantages to take advantage of and use our telescope facilities to implement that technology, it usually opens up new areas of science, which is very exciting.
Yeah, for sure. So the collaboration is huge. It's like a team effort for sure.
Absolutely.
So for the team, what are some current challenges that they're facing either in research or helping the public connect with science?
So it's always important for the public to understand the importance of what we do and why it's important to understand basic research and how that helps us understand what we see in our own universe. It's human curiosity. Why do we want to understand our solar system? Why do we care about the Milky Way galaxy? What do we not understand about the universe? And how can astronomers address those kinds of questions? In terms of challenge, I would say that the data rates are very challenging that are coming off of our telescopes and that will come off of the telescopes in the future. And one of the things I really like about astronomy is, again, we are very collaborative, but it takes a very talented group of managers, scientists, administrative folks, business people, engineers, computer scientists, software engineers to make everything work. And so we take an enormous amount of data. So for folks who are interested in going into a scientific and engineering field and participating in the field of astronomy, we need people who are talented at data science. And, obviously in the news right now, machine learning and artificial intelligence are very important and are in the news a lot. And so we pay very close attention to all of these new developments in science and technology and computing to figure out how to better operate our facilities, how to analyze our large amounts of data and how to deal with those large amounts of data, and to use all of that together to produce well-managed scientific facilities that can help the astronomical community.
That's really, really cool. Talking about complex data, do you have any tips for possibly a small brand trying to learn how to present complex information in an engaging and visual way?
So obviously radio telescopes are quite photogenic, as you can see from the image behind me here with the moon rising over the very large array. So having those kinds of visual representations makes people very curious about what we do and how we aim to accomplish those kinds of things. The high resolution data that we take off the telescope right now produces just spectacular images. And so I think using those images from our radio telescopes to show galaxies and planetary debris disks forming, it really, really captures people's imagination. And that's one of the exciting things about astronomy and why we like studying that area of science so much.
For sure, that curiosity, that wonder, that humanly instinct to find out more.
That's right.
So, can you tell us about a moment in your work where you truly felt the scale or the beauty of the universe, something that gave you goosebumps or changed the way you maybe have seen things in the past?
Well, that happens all the time. And I always like to say that astronomy is a science of the extremes. We have some of the largest facilities that have been built by humans studying the furthest distances in the universe with some of the most extreme environments that exist, that don't exist, on planet Earth, that we are in no way, shape, or form used to. And everything that we do with our radio telescopes is done through what we call remote sensing. It's unique in that sense because if you're a biologist or a geologist, you're working, or a chemist, you're working in a laboratory. So you're actively working on your experiments there. You're taking samples in the field and doing your scientific studies that way. Everything we do, we get from detecting electromagnetic radiation from large distances in the universe. And so we have to protect those data very carefully and make sure that everything is recorded accurately. And that makes it a very unique science. It makes it very challenging because in many circumstances, we only get one opportunity to observe a time-dependent phenomenon. We can't replicate that experiment in a laboratory for the most part. We can only make observations. And that's one of the things that makes our scientific facilities very unique.
That's amazing. So, what does a huge facility like this mean for the world in general? What type of outcomes are we looking for out of this?
So our facilities, in addition to doing technology development and basic research, we also use our facilities to calibrate things that are important for people like GPS. So those are the outcomes of using our telescope facilities, and it's just one of the things, practical things that we do with our telescopes. The technology development and a lot of the instrumentation that goes into our facilities has applications in other parts of society. But I think with astronomy, it's the wonder of, what is out there in the universe and capturing human curiosity that is what makes it so incredibly important to do.
That's awesome. So, if you were away from work and you had a day to spend completely free, however you'd like, what would you be doing?
Well, astronomy takes a pretty good amount of my time, but I feel very fortunate to be able to do that because I think it's very, very important to study and understand the universe. But if we are away from the observatory, we're usually out talking to the scientific community and the public at a whole host of different types of astronomical and scientific and engineering conferences. We go to computing conferences. We go to technology development and engineering conferences. And we talk to our astronomical user base. So that keeps us pretty busy because there's a lot of really, really great astronomical phenomena out there to study.
For sure. So, if somebody was looking to follow along, learn more, or connect with you about radio astronomy, where would they go?
So you can check out our website and our social media. My personal astronomical social media handle is Visualize Astronomy or Viz Astro. And you can go to our website at science.nrao.edu. And that will tell you everything that you need to know about the National Radio Astronomy Observatory and our facilities.
All right. Well, you guys heard him. Be sure to check out those social medias. I've checked them out for myself, and they are just stunning. The images to the articles, everything is worth a read. So be sure to check it out. That's a wrap on another episode of Behind the Print podcast. Thanks to our listeners for joining us as we've explored the artistry and innovation of the printing world. Remember, having a strong vision, building the right strategy, and using tools like print to amplify your message will make your brand stand out from the crowd. If you've enjoyed today's episode, stop by printingcenterusa.com and grab a free sample pack and share it with your fellow business enthusiasts. Until next time, keep those creative sparks flying, and remember, there's always more to discover behind the print.